Hey guys, this is your Mobile Minute. What is 5G spectrum? Broadband signals for mobile networks are modulated to allow them to travel without interfering with other operators or signals from other technologies, like satellite. If we imagine FM radio, the actual signal we're trying to receive is within the audio spectrum. It doesn't matter whether it's a DJ spinning Taylor Swift songs or a host talking about politics. If all stations simply tried to broadcast using the same baseband frequencies, it would be a garbled mess because we'd be hearing every Taylor Swift song at the same time. Instead, FM radio uses channels to minimize interference, and also it allocates these to stations via a licensing process. FM falls within the VHF part of the radio spectrum, which means it runs from 87.5 MHz to 108 MHz. An interesting thing about frequencies is that lower frequencies travel further than higher frequencies. We've all heard the of a car before the car actually rounds the corner, and the same is true for mobile spectrum. If we think of the FM example again, many of us probably already know that AM radio sent at the same power can be received further away from the antenna than FM. And that's because AM operates much lower than FM, between 535 and 1605 kHz. FM can practically travel about 50 kilometers, where AM is probably twice that. Mobile signals are modulated in a similar way to FM and AM, primarily with three types of spectrum: low, medium, and high. And each of these is chosen based on a variety of factors, including price, availability, capacity, and propagation. That's the distance a signal can go before it can no longer be usable. Low band operates between 1 GHz, and in previous generations of mobile technology, it mostly focused between 800 and 900 MHz, going as low as 400. These low bands are golden because they allow operators to build out coverage at lower cost because of the density of cell sites being lower. Unfortunately, it's typically in use for other functions, and so it doesn't offer enough bandwidth to carriers. It's typically allocated in chunks of 5 to 10 MHz. During early deployment days of mobile networking, coverage was the primary goal. It wasn't really until 2G had matured that capacity became equally important, and even more so when we introduced mobile data services. Mid-band spectrum operates between 1 GHz and 6 GHz, and it's often referred to as sub-6 G. Because of the higher frequency range, it can't travel as far, but it does have more frequency available for use, and that's important for operators. As such, it's used to complement lower spectrum by offering a combination of coverage and capacity. High-frequency spectrum, or millimeter wave, operates above 24 GHz, and you guessed it, the waves are below 1 millimeter. And it offers huge amounts of frequency for use, but unfortunately, only at very short distances. Often when you hear about 5G speeds approaching hundreds of megabits per second or gigabits per second, this is happening in the millimeter wave spectrum. It's great for addressing hotspots like dense urban areas, stadiums, and conference centers, but it probably has more limited applications for the general public as the signals cannot reliably penetrate walls. For practical deployments, millimeter wave is basically line of sight, meaning if you can see the antenna, you can probably get a pretty good signal. Operators need to balance between coverage and capacity based on user demand and any other commitments that they might have made with a local regulator. At the same time, they have to consider the location of existing cell sites, since deploying 5G at 2.6 GHz is considerably easier if an operator already has 3 or 4G deployed at something like 2.1 GHz. Shifting to a new band like 3.5 or C-band could mean significant redesign is necessary since the cell sites were originally deployed assuming a larger cell radius than maybe 3.5 GHz can support. Millimeter wave will mean a complete rethink in how cell sites are deployed, since macro cell towers won't be usable. Instead, millimeter wave will be deployed on lampposts and street signs and other locations closer to the user. Maybe more important going forward is that with all these different spectrum options for operators, we'll need a sophisticated system to coordinate between them and allow users and devices to connect to multiple bands simultaneously. And this is why artificial intelligence is so critical for 5G deployment as new spectrum gets introduced. That's your Mobile Minute. Thanks for watching.